Hi, actually this video is about finding inverse Laplace transform of a function. Inverse Laplace transform of a function. So let us take, so basically the background is, suppose if you have a function in time domain like a real time signal f of t, we want to analyze this signal in frequency domain. We convert this signal into frequency signal by using Laplace transform. This is the one of the technique to convert time domain signal into frequency domain. This is f of s, and if you want again the time domain signal, you need to apply the inverse Laplace transform to find the time domain signal or original signal. So now we are focusing on this segment, inverse Laplace transform. So let us take, suppose we are having f of s, s by s plus 1, s plus 2. This is a inverse Laplace, this is a function f of s. We need f of t, inverse Laplace transform of this function. Actually inverse Laplace transform is a basic concept in electrical engineering. So for this, so we need to this is a proper fraction. So first step one, so we need to convert into partial fractions. Need to convert into partial fraction expansion. So this is a proper fraction, so no need to change anything. S plus 2, and the partial fraction expansion is a by s plus 1 and b by s plus 2. So now, so s by s plus 1, s plus 2 is equal to s plus 1 into s plus 2, taking LCM here, and a into s plus 2 and b into s plus 1. Now these two get cancelled each other, so s is equal to a into s plus 2 and b into s plus 1. So now we need to find here a and b values. So how do we get? Suppose if I put s is equal to minus 2, the above equation, what it gives, s equal to minus 2 and a into 0 and b into minus 1. So it is b is 2. The same way, if we put s is equal to minus 1, now it becomes a minus 1, and minus 1 plus 2, it is 1, and b 0. So a is equal to minus 1. So now our function f of s is a minus 1 by s plus 1 plus b 2 by s plus 2. This is a partial fraction expansion of our function. So now we are ready to apply inverse Laplace transform. Before that, we're going to check some basic formulas. So suppose you're having h of t, u of t. So if you apply Laplace transform, you get 1 by s. Same way, e power minus at u of t. The inverse Laplace transform for this function is 1 by s plus a. So these two formulas we are going to use now. So f of t is equal to, our function changes like this, is equal to minus 1. So here just compare these two, and in the place of a we have 1, so a here is 1. So how much it will become? E power minus 1 times t u of t. The same way, 2 into, here in the place of a we have 2, so it's e power minus 2t u of t. So therefore our function f of t, time domain function, is e power minus t u of t plus 2 into e power minus 2t u of t. So we can write in a more compactable form, like 2 into e power minus 2t minus e power minus t u of t. Otherwise there is another form. So we know the u of t is a unit step signal, u of t, and this is a t. It is 0 for t less than 0. this is t less than t, this is t is equal to 0. For t less than 0 it is 0, for t greater than 0 it is 1. So if you put 1 here, 1, it is 2. If you put 2, it is 2, like this. So in our case it is u of t, only 1, so it is 1. So how can you write this? Again, the final step, 2 into e power minus 2t e power minus t for t greater than 0, like this. Because it is 1 for t greater than 1, so no need to use u of t, just use the time signal. Thank you. I hope you like this video. Thank you.